logarithm function. The first thing we're going to learn how to convert from the log form to exponential form. First of all, we're going to study the log form, how it's look like the log form. Then we're going to convert to exponential form. So let's do log form. If we have, this is the rule, the general rule about the log form. 1 second. So if you have log, this is the log form, how it look like. You see, that's why I put the sign. This is the symbol about the logarithm. So log to the base a to the x. X, which is the number, a, it's a number. So this is the log form, log to the base a for x equal y. So this is the log form. So sometimes you will get this one and they ask you to convert to the exponential form. Or they're going to give you the exponential form and they're going to ask you to convert to the log form. So this is the log form. Log to the x to the base a, or log to the base a for x equal y. So now to convert this one to the exponential form, we're just going to do one thing, move the base from here is going to be base to the y. So that means here's the, you see, here's the equal sign. I'm gonna move the base because this is a base. So I'm gonna move the base from here to be a base for the y. So it's gonna be base for the y. That means y is going to be an exponent. I'm gonna move this one, is going to be here and cancel the log. So the leftover just x. So you see, this is the log form, this is the exponential form. So to convert this one, I'm just going to move the base from here, from the log, to be a base for the y, and cancel the log. The leftover from the left side is the x, and for the right side is going to be a to the y. Let's do an example about that. If you have log to the base 4, 1024 equal 25 or equal 5. So you see, they're going to give you this example. They ask you to convert to the exponential form. So how are we going to convert to the exponential form? We're just going to move the base from here to be a base for the other side. So here's the equal sign. It's going to be 4 to the exponential 5 to the exponent 5. And the leftover from this side is just 1024. To check your solution, if you plug in here in the calculator 4 to the exponent 5, is going to be 1024, 100%. Let's do another example. If you have log to the base 64 to number 4 equal 1/3. This is the log form. If they ask you to write down the exponential form, we're just going to move the base from here. It's going to be base to the other side. So it's going to be, here's the equal sign. It's going to be 4 to the power, sorry, 64 to the power 1/3. And the leftover from the left side is just 4. So if you plug it in the calculator, 64 to the exponent 1/3 is going to be 4. So that's how we're going to convert from the log form to the exponential form. Let's do another example. If you have log to the base 8, 512 equal 3. We're going to do exactly the same thing. We're going to move the base from here to be a base for the other side. So here's the equal sign. It's going to be 8 cubed. 8 cubed. The leftover from the left side, we're going to cancel the log, just 512. That's how you're going to convert from log form to the exponential form. From log form to the exponential form. Now, let's do the opposite thing, how to convert from the exponential form to the log form. Because they're going to ask you both sides. They're going to ask you convert from the log form to the exponential form, and also they're going to ask you to convert from exponential form to the log form. We have to use exactly the same rule. It's only one rule here to convert from the log form to the exponential form, or the opposite thing. So you see, we're going to do exactly the same process. I'm going to write down the rule here. Y log to the base a to the x equal y. This is the log form. And I'm going to write down the exponential form by converting this one to the other side. So the leftover on the left side is x. It's going to be a to the exponent y. So this is the rule. Now, if they ask you to convert from the exponential form to the log form, for example, if you have 5 squared equal 10, 5 squared equal 25. 5 squared equal to 25. This is exponential form. That means this is exactly the same thing here. So what I'm going to do, if you don't want to do any mistakes, okay, you can reverse these, flip these two numbers. 25 equal 5 squared. I need to write down the log form. So check, the 25 is the x, the 5 is the a, the 2 is the y. I need to write down the log form, so I'm going to write down log. Where is the number? The x is going to be here with the log, so 25 equal. The base is going to be the 5, a. The base is going to be 5, so I'm going to write down 5 here. On the last thing, the leftover is the y, which is the y is 2. So that's how we're going to write down. We're just gonna reverse the process. We're gonna bring back the a to the other side, bring back the a to the other side, and write down again the log. Here's the a, because I'm gonna bring back the a, and here is the x, and the leftover now here is going to be y, which is this is exactly the same thing here. Let's do another example. If you have 1/4 equal 2 to the negative 2. The same process. This is the x, this is the a, this is the y. To write down the log form, here's the log. The base, where is the base? This is the x. I'm going to write down the x here. Write down the base by bring back the 2 to the other side. So here is the 2. Here's the equal sign, and the leftover is negative 2. That means we're going to bring back, here, let's do it here. To bring back this one as a base, I'm going to write down the log, bring back the base a, this is 1/4, and the leftover on this side is going to be negative 2, which is exactly the same thing here. This is how you're going to convert from the log form, from the exponential form to the log form. Let's do one more example. If you have 1,000 equal 10 cubed. This is exponential form. We need to write down the log form. So what I'm going to do, I'm going to bring back the base. The base here is 10. I'm going to write down log. The base is 10. And I'm going to write down the x, which is the 1,000, equal the leftover on the right side is just 3. That's how we're going to convert from the exponential form to the log form. If you have any questions about how to convert from the log form to the exponential form or the opposite thing, you can ask before we move on to the next part. The next part is how to evaluate the logarithm. I'm going to show you 2 methods about how to evaluate, but the easiest one, if they ask you to evaluate, you can use the calculator, it's fine, or you can use the method to find how to evaluate. I'm just going to make it easier for you. So if you want to use the calculator or you want to use a method to evaluate, let's do the same thing. There's 2 methods about the evaluate. I'm going to show you also how to use the calculator. So if they ask you to evaluate the logarithm, so for example, they ask you to evaluate log to the base 3 1/3. That means we need to find the value of log to the base 3 1/3. How are we going to find this value? So the first thing, I'm going to write down this. I'm going to say it's log to the base 3 1/3 equal y. I'm going to write down the log equal y. I need to find the value of log to the base 3 1/3 equal y. Now, this is the log form. I'm going to convert it to the exponential form. How? By moving the base from here, is going to be base to the other side and cancel the log. So it's going to be the leftover 1/3 equal 3 to the base y. Now we need to keep going to find the value of y, which is going to be the value of everything here. So how are we going to solve this one? I'm going to move this one by using the rule. If you remember, we have the exponent rule. This is the exponent here is 1. I'm going to convert it from 1 over a number with positive exponents to the number with negative exponents, equal 3 to the power y, which is this rule. If you have 1 over a number to positive exponents, it's going to be the same thing, the number with negative exponents. Now, if you remember, if we have the same bases, equal bases, that means we have equal exponents. So I'm just going to write down the exponents, y equal -1. This is the result. That means log to the base 3 1/3 is going to be equal -1. So here's the process. You have, I'm going to write down everything here equal y. Then I'm going to convert it from the log form to the exponential form by moving the base to the other side. Then I'm using the exponent rule by moving 3 to the exponent 1 on the top by using this rule. Then I have equal bases. That means I have equal exponents. So y equal -1. That means the log for base 3 1/3 is going to be equal -1. Let's check how we're going to find this one by using the calculator. This is the math way, but to use the calculator, let's do the same thing. The first thing, to find the log with base, you're going to click on the math here. Now, you can't find the log. You have to scroll down until you see log base, parentheses. This is the log to the base, the last one. Log to the base. Click, you see now, this is the log to the base. I'm going to write down the base here, which is the base, I have it 3. And 1/3, that means 1 divided by 3. So the result is going to be -1. So here's the two methods. If you want to use this method or you want to use the calculator, it's fine. I'm not going to say no, but you have to learn how to use as a math way, not using the calculator. Let's do another example about that. I ask you to find the value of this number. You have two options. You can use this method or you can use the calculator. It's fine. How are we going to find it? We're going to assume everything here equal y. Then I'm going to convert from the log form to the exponential form. How? By moving the base form here is going to be base to the other side and cancel the log. So 64 is going to be equal 1/4 to the exponent y. What I'm going to do here on this side, I'm going to use the same rule here by moving 4 to the top. So it's going to be 4 to the exponent -1 to the y equal 64. I'm going to analyze the 64. How are we going to analyze the 64? Let's do it here. 64 divided by 4 is going to be 16. 16 by 4 is going to be 4. 4 by 4 is going to be 1. So 64, I can write down 64 as a 4 cubed. So I'm going to write down here 4 cubed. I can multiply these two exponents. So it's going to be 4 to the -y equal 4 cubed. Now I have equal bases. That means I have equal exponents. So it's going to be 3 equal -y. I need to find the y, not -y. So I'm going to divide both sides by -1. So y is going to be -3. That means log to the base 1/4 to the 64 is going to be equal -3. This is the solution. You see the solution, we can't find it using the log, so we convert it to the exponential form, and we simplify by using the exponent rule and find the result y equal -3. That means log to the base 1/4, 64 equal -3. Let's check that by using the calculator. So we're going to go math. So go down to the last one, which is log to the base. Now we're going to type the base 1/4. That means 1 divided by 4. This is the base. To the number 64 is going to be equal -3, which is exactly what we got, -3. So this is the second method. If you want to use this method to practice on it, or you want to use the calculator, that's fine. Log, we're going to evaluate log to the base 10 to the 1. That means we need to find the value of log to the base 10 to the 1. So what I'm going to do, I'm going to say log to the base 10 to the 1 equal y. So this is the log form. Next step, I'm going to convert this one to the exponential form by moving the base from here to be a base for the y and cancel the log. So it's going to be 1 equal 10 to the exponent y. And here is the important thing. One of the exponents rule, it says if you have any number with exponent 0 is going to be 1. So if I said 10 to the exponent 0 is going to be 1. So I can convert this one to 10 to the exponent 0. Because 10 to the exponent 0 is going to be 1. And here's 10 to the exponent y. Now we have the same bases. That means we have the same equal exponent. So y is going to be equal 0. So that means log to the base 10 to number 1 is going to be equal 0. If you're using the calculator, you will get exactly the same result. Sometimes when you're doing these steps, you're going to get undefined. But when you're using the calculator, it's going to be error. First of all, let's check this one, and I'm going to give you an example about this case. So here we're going to press math, log to the base. I'm going to check log to the base 10 to the 1. So the base is 10, and I'm going to write down number 1 here. So it's going to be 0. So our solution is right. Now let's check this example. Evaluate log to the base 9 to the 0. We need to find how much. So I'm going to write down log to the base 9 to the 0 equal y. Then I'm going to convert to the exponential form by moving the base from here to be base to the other side. So the leftover here is going to be 0 equal 9 to the exponent y. Now in this case, you can't find a number with the base 9 to any exponent, and the result is going to be 0. You can't move on this case. That's why this log to the base 9 to the 0 is going to be undefined. It's going to be undefined. Even if you're using the calculator, because there is no number with base 9 and any exponent equals 0. 9 to the exponent 0 is going to be 1, not 0. 9 to the exponent 1 is going to be 9. 9 to the exponent 2 is going to be 81. So there is no number you're going to plug in here to get 0. That's why you can't move on. So log to the base 9 to the 0 is going to be undefined. Let's check that. If we use the calculator to find the solution for this one, you will see the difference. Log to the base 9 to the 0. Not a number. You see, sometimes not a number, or you're going to get an error. That's mean undefined. Undefined. So be careful with this case. If you're using the calculator and you find this result, that's mean undefined. Just write down undefined, and that's it. That's if you're using the calculator, is going to be none a number. It's mean undefined. If we have about evaluate, if they ask you evaluate log to the base 2 to the negative 5, that means we need to find the value of this one. So what we're going to do, I'm going to just say log to the base 2 to the negative 5. You don't have to put parentheses. Equal y. So this is the logarithm form. We're going to write down the exponential form by moving the base from here to the other side and cancel the log. So the leftover from the left side is negative 5 equal 2 to the power y. Now we have to work on this one. How are we going to write down? Because I have negative 5 equal 2 to the y. Even if you can't move this one on the bottom, and you can't find a number with base 2 to the power negative 5 to simplify this one to write down negative 5 as a 2 to the exponent. That's mean until here you can find the solution. So it's going to be undefined. Log to the base 2 to the negative 5 also is going to be undefined. Let's check that by using the calculator. We're going to type log, here is math, log to the base. Type the base is 2 to the -5, is going to be, this is, you see, this is, you got not a real number. This is not a real number. This is a complex number, and we're not going to use this result as a complex number. So just write down undefined. So always we're going to work with the real number. It's a complex number because this is the real part plus the imaginary part with I. We're not going to write down, they're not going to ask you to write down your solution as a complex number when you're doing the homework, the online homework. You have to write down your answer as a real number. That's how you find, evaluate. So the easiest way, if they ask you to evaluate, you can use the calculator, it's fine. But the main thing, if they ask you to solve the equations, solve the logarithm equations, that means we need to find the value of x, but there is a logarithm. We're going to use exactly the same process. We're going to convert from the log form to the exponential form because it's going to be easier to work with the exponential form. For example, if they ask you to solve the equations, that's the only thing they're going to tell you. They're not going to tell you it's a logarithm equations. They're just going to ask you to solve the equation. That means we need to find the value of x. So log to the base x to the 9 is going to be equal -2. That's the only thing they're going to ask you. Solve the equations. They're not going to tell you, oh, be careful, this is a logarithm equations. They're just going to ask you, solve the equations, and you're going to know it's a logarithm equations because there is a log here. So the first step you're going to do, we need to find the value of x, and the x here is the base. We're going to convert from log form to the exponential form. So I'm going to move the base from here is going to be a base to the other side. Cancel the log. The leftover from the left side is 9 equal x to the -2. Let's do one more step. Now, can I analyze the 9? And I need to convert this number to a positive exponent. So I'm going to use exactly the same rule. If I have a number with negative exponents, I'm going to convert it to 1 over the number with positive exponents. So I'm going to convert this one here is going to be 1 over x to the positive exponent equal. Can I simplify the 9? Yes, the 9 equal, I can write down 3 squared. So I'm going to write down the 9 as a 3 squared. Next step, x squared. If I square the 1, it's going to be the same result. If I say 1 squared, it's going to be the same result. So what I'm going to do, I'm going to say it's 1 over x squared, because 1 squared is going to be 1. X squared is going to be x squared. So I didn't do anything here. I just took the squared is going to be for the 1 and for the x. Because 1 squared is going to be 1, x squared is going to be x squared. And here is 3 squared. Now we're going to use the rule. It says if you have equal bases, that means you have equal exponents. If you remember, equal bases is going to be the same thing, that means equal exponents. And the same thing, if you have equal exponents, that means you have equal bases. So in this case, I have equal exponents. So that means I have equal bases. So 3 is going to be 1 over x. Now I have to keep move on. I need to find the value of x, not 1 over x. So what I'm going to do, 1 over x equal 3. I'm going to flip this part. 1 over x is going to be x, and the flip this part is going to be 1 over 3. That's it. The reciprocal for both sides. The reciprocal of 1 over x is going to be x. The reciprocal of 1 over 3 is going to be 1 over 3. That means the value of x is going to be 1 over 3. So that's what they're going to ask you. This is really important because they're going to ask you just to solve the equations. And you will see it's a logarithm equations. So we're going to use exactly the same process.
Sure, and we can do that on the calculator?
I don't think so. You can do that in the calculator. Because the base here is x is the variable. So you have to do the same process. And you will see the next example, we're going to do exactly the same process. So put a star on this one because this is important. So here is the next example. If they ask you solve the equations. You're going to solve log to the base 4 to the x equal 3. So check this one. This is log form. They asked me to solve. That means I need to find the value of x. I can't do it here. So I'm going to convert to the exponential. Move the base from here is going to be base to the other side and cancel the log. So it's going to be the leftover from this side is just the x equal. I'm going to move the base from here. It's going to be base to the other side. So it's going to be 4 cubed. That's it. You see the x by itself and everything on the other side. So that means x is going to be equal 4 cubed is going to be 4 times 4 times 4 is going to be 64. This is the solution for this one. Solve the equations. If you have log now to the base x minus 5 to the 10 equal 1. The same thing. This is, you see the base? The base on this example is x minus 5. So to solve this one, we're going to convert it to the exponential form. How? By moving the base from here is going to be base to the other side. Cancel the log. So the leftover on this side is 10 equal x minus 5 to the exponent 1. X minus 5 to the exponent 1 is not going to affect anything. It's going to be x minus 5 equal 10. Now, how are we going to find the value of x? We're just going to move the 5 to the other side because this is a linear equations. So add 5, cancel these. So x is going to be equal 15. That's it for this example.
Sir, can we try another one when the base is just x?
Just x, let's see another one. When we need to find the solution, we need to keep the x by itself on one side and everything on the other side. Like all the numbers with the log, everything. But if you check this example, the x is already on one side. So if you go ahead and plug in everything here in the calculator, I'm going to show you also if you want to solve it with the long way. But let's check the easiest way. X by itself, if you check when you need, on the previous example, when we found the solution, x equal a number. That means the x on one side and everything on the other side. So the same thing here. It's already the x by itself. So the x on one side. So I'm just going to say, let's plug this one here on the calculator. Math, log to the base, the base is 3, and I'm going to say 1/27. So it's going to be -3. That means this side equal -3. And the other side equal x. That's it. That's been the solution x equal -3. This is the easiest way. If you want to use the long way, which is, let's say you didn't figure out this method. You say, like, you didn't figure out, like, I'm going to plug in everything here in the calculator to get the how much is going to be here. That's mean x equal -3. So we're going to convert from the log form to the exponential form. Let's do the long method. I'm going to move the 3 from here. It's going to be 3 to the other side. So it's going to be cancel the log. The leftover 1/27 equal 3 to the x. Now let's move the 27 to the top by using the rule. It says if you have 1 over a number with positive exponents, it's going to be the same thing, the number with negative exponents, by using this rule. So it's going to be 27 to the -1 equal 3 to the x. Now, can I simplify the 27? The 27, let's do it here. 27 is 3 times 3 times 3. That means I can write down 3 cubed. So I'm going to say 3 cubed. And here is the -1 equal 3 to the x. Can I multiply these two exponents? Yes. So it's going to be 3. 3 times -1 is going to be -3 equal 3 to the x. I have equal bases. That means I have equal exponents. So I'm just going to write down the exponents, -3 equal x. The same solution. So if you plug in everything here in the calculator, you will get -3. If you didn't notice that, you can do that. You can do this method by converting it from the log form to the exponential form. Then here on this side, analyze the 27, which is 3 cubed. Or you're going to move the 27 on the top. Is going to be 27 to the -1, because the exponent here is 1. When I move it on the top, it's going to be -1. Then 27, factor the 27, which is 3 cubed. So 3 cubed, multiply 3 with -1 is going to be -3. Then I have equal bases. That means I have equal exponents. So -3 from this side equal x, which is exactly the same result. Let's do another example about how to solve the equations. Let me give you more time to write down these. And let's solve this one. If you have log to the base 1/4 x plus 51 equal -3. Before we solve this one, let's solve this one. We're going to do exactly the same process. We need to find the value of x. And you see, with this example, I can't plug in the calculator, so that's why you have to use the same method. Convert to the log form, because the x is going to be the angle for the log, so you can't use the calculator. So convert to the exponential form by moving the base from here is going to be base to the other side. Cancel the log, so the leftover here is going to be x plus 51 equal 1/4 to the -3. Now here's the thing, x plus 51, you can't do anything. This part here, you can use the calculator. You're just gonna say 1/4 to the -3. This is another easy method. So the first step, you convert it to the log exponential form. Then you can use the calculator to simplify this part. Just gonna say 1, you have to open parentheses, 1 divided by 4, close the parentheses, to the power -3. Oops. To the power -3 is going to be 64. So I already know the result here is 64. Now, we're just going to say minus 51 from both sides. Minus 51 from both sides. Cancel these. So x is going to be equal 13. So that's how you're going to use it. But let's go back to this step. If you don't want to use the calculator, let's do this step again. And I'm going to show you how you're going to get the same result. X plus 51 equal 1/4 to the -3. Now let's check this one. Let's take the reciprocal or use the rule, because the 4 with the exponent 1, I'm going to move it to the top. So x plus 51 is going to be 4 to the -1, and here's -3. I can multiply these two exponents. So x plus 51 is going to be 4, -1 times -3 is going to be 3. So x plus 51 is going to be 4 cubed, which is 64. So we got exactly the same thing here. Now minus 51 from both sides, cancel here. So x is going to be equal 13. That's if you don't want to use the calculator, you're just going to go ahead and use these steps. If you want to use the calculator on this side, it's going to be already 64 minus 51 from both sides. So the result is going to be x equal 15. 13. Let's take some properties about graphing. So to graph logarithm function, how we have to notice that. So here is f of x equal log to the base a to the x. Now again, we have two options to graph. We have two options. If a is greater than, sorry, not 0, greater than 1, and if, which is the base, a between 0 and 1, that means decimal number. So here's the two options, how the graph is look like. If a is greater than 0, always the graph is like this. It's going to be like this, always. On this side. If it's a decimal number, always the graph is going to be like this. On this side also, because the range always, the domain, we can take it from 0 to infinity. We can't take the negative number because it's going to be an error. So it's going to be like this. So that's, it depends about the a is between 0, which is the base, between 0 and 1, which is the decimal number, or a is greater than 1, the graph is going to be look like this. Always the domain from 0 to infinity, and the range for the logarithm function, negative infinity to infinity. Be careful, the domain from 0 to infinity, the range from negative infinity to infinity. Let's do a graphing about that, simple questions. If you have graph f of x equal log to the base 4 to the x. This is a simple one. I'm going to check the base. the base is 4, that means greater than 1. So my graph is going to be look like this. Now, how to graph it? My domain from 0 to infinity. So from 0 to infinity, I'm going to pick at least 3 numbers. So let's take 3 numbers. The first number, let's take negative, or take x equal half, and take 1, and take 2. You see, 3 numbers is going to be enough. Now let's plug in these 3 numbers in our function to get the graph. So the first thing, I'm going to plug half here. So it's going to be log to the power 4 to the half equal what? So let's check that. We're going to use the calculator. That's why I'm telling you it's easier for you, because you're going to use the calculator. So let's plug log. Let me math. Log to the base. And the base is 4. I'm putting half here, which is 1 divided by 2. Sorry, not here. 1 divided by 2. And the result is going to be negative 0.5. That means the first point is going to be half and negative half, because 0.5 is half, so it's up to you. How we're going to write it down is going to be fine. Do not confuse you. Let's write down 0.5. So it's going to be 0.5 and negative 0.5. This is the first point. Now let's plug in 1. So it's going to be the same fraction with the same base, but I'm going to plug in just 1. So the result is going to be 0. So when it's 1, it's going to be 0. That means the point is going to be 1 and 0. Let's plug in 2 here. So it's going to be the same one, but instead of the 1, I'm going to write down 2. And the result is going to be 0.1. So the result is going to be 0.5. So that means it's going to be 2 and 0.5. So you see, 3 points is going to be enough to graph the logarithm function. So I'm going to do the graph here. This is the 1. This is negative 1. 1, 2, negative 1, negative 2. So the first one, 0.5 and negative 0.5. That means here is 0.5 and here's negative 0.5. So it's going to be here. This is the first point. The second point, 1, 0. This is the 1. 0 is going to be here. And the third point is going to be 2 and half. This is 1, 2 and half is going to be here. That means our graph is going to be like this. Goes down from this side, goes up like this, and up, keep going up like this. So this is the graph of this function, and you will see a, which is the base equal 4. That means greater than 1. So the graph is look like this one. So this is another part how to make sure you got the right answer. Pick 3 points, and make sure the 3 points is going to be like this between the domain 0 and infinity, because always the domain equal from 0 to infinity, and the range negative infinity and infinity always. So make sure when you're picking the domain, pick the numbers. You see, half, 1, 2, or half, 1, 2, 3. You will get this.
Sir, how do you find the point 0.5 through 0.5?
How I find what?
The point on the graph.
On the graph, okay. So you see, this is 1, this is 2, okay? So let's graph 0.5. 0.5, that's mean half. So when you get example on when you're doing homework, it's going to be more accurate, okay? So the half, that means here's the half, between 0 and 1. Half, that means 0.5, which is, here's, I'm gonna make it easier for you. So when you graph it here, so let's say this is the 1, okay? This is the 2. If you want to graph it like this. So say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 1, okay? Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you want to make it so accurate, 9, and here's the 10. Now this is 1, this is 2, okay? 0.5, 1, 2, 3, 4, 5 is going to be this point, which is 0.5, okay? So if you want to do like this to get accurate solution, but the main thing when you're doing on the online assignment, you already see these, it's going to be easier to pick the 0.5, okay?
Okay.
But
if it said x 0.5 and y 0.5, it should be in the middle?
In the middle, yes. Like this point, 0.5 and negative
Yes.
0.5. Okay, so this point, 0.5, 0.5, and negative 0.5. 0.5 in the middle here, right? What about negative 0.5? It's going to be in the middle between negative 1 and 0. So it's going to be here, right?
Yes.
Mm-hmm. That's what I did. Here, if you check this one, this is the point. This is 0.5, and this point is negative 0.5. Okay, so here is the point. And here is 1, 0, this one. And 2.5 is going to be, here's 1, 2, and this is the half. Okay, going to be here. So the graph is like this. So now let's study the properties of logarithm, which is going to help a lot about simplify the logarithm. So the first properties, first one, if you have log to the base a x times y, x times y, that means the multiplication between two numbers, like 2x, xy, the same thing, 2x, 2 times x. So how we going to simplify this one is going to be log to the base a x plus log to the base a y. So when you have multiplication between two numbers, log to the base multiplication between two numbers is going to be log to the first number plus log to the second number. So this is the first property of the first rule. The second one, it's if multiplication, the first one, the second one is if it's division. So if you have log to the base a x divided by y. So division between two numbers. So it's going to be log to the base a x minus log to the base a y. So here is the first two rules. Log to the base a x times y is going to be addition. Log to the base a x plus log to the base a y. Log to the base a x divided by y is going to be log to the base a x minus log to the base a y. So here is the first two rules. The third rule, these three rules, the first three rules are really important. If you have log to the base a x to the exponent r. Now, first of all, we have one number, but this number with the exponent. This number with the exponent, how are we going to do that? we're just going to move the exponents, is going to be in front of the log. So it's going to be r log to the base a to the x. You see, we're just going to move the exponent in the front. So if you have this part, you can convert it to this part. If you have this part, you can convert it to this part. It's up to you. It depends about how they're gonna ask you. So here's the first 3 rules. Let's add one more rule. 1, 2, 3. Let's add, yeah, rule number 3, this one. Rule number 4. If you have log to the base a to the 1, always is going to be equal 0. Always. Log to any number, log to the million to the 1, always going to be 0. Log to the 5 to number 1, always going to be 0. So this is rule number 4, the first part. The same thing if you have log to the base a and the number a is going to be equal 1. That's mean here, the second part. If you have log to the base and the number exactly the same number, so the result is going to be equal 1. So this is rule number 4, contains 2 parts. Log to the base a to the 1 equals 0. That means if you have base here any number, but the number here is 1, always going to be 0. Log, if you have the base and the number exactly the same, so it's going to be equal 1. This is rule number 4. Rule number 5, also 2 parts. If you have log to the base a, and here's the number with x. Now we have a number with x. So the result is going to be just an x. If the number are the same base, but there's an exponent here, that means everything here is going to be 1, and the result is going to be just the exponents here. This is the first part. The second part, if you have a number with exponents, and the exponent is log to the base a to the x. The exponent is log to the base a to the x. So the result is going to be also an x. So here's the rules for the logarithm. Let's start doing examples. I need you to write down these rules before we start doing examples. Which rule are you going to use when we start the first example? So check the first example, we're going to do it. Let's do this one. So here's an example. If you have log to the base 2 to the exponent -5. Who's gonna tell me how much the result and which rule? Check one of these rules similar exactly what we have here. Which rule is similar to this one? Someone tell me.
Number 5.
Number 5, this part or this part?
The first part.
The first part. So how much is going to be the result here? Check here. Rule number 5, the first part. A, and here's the x. The result is going to be x. Where is the x here?
-5.
-5. So just write down -5. That's it. That's why I need you. I gave you the rule. You're just gonna check which rule is similar to this one. Here's the second one. If you
Sir,
have,
I didn't understand the problem. I'm sorry.
the problem is they give you this part and they're telling you, give me the result, okay? So it's up to you. If you want to use the calculator, it's fine. It's going to be -5. But if you want to use the rule, you see rule number 5, it says log to the base a to the a and x. Check this rule with this example. Log to the base 2 and the 2 to the negative 5, the same number here. So the result, how much the result is x, which is the number here. The number here is negative 5, so it's going to be negative 5.
Okay.
If you want to use,
we can use the calculator on this kind of problems.
With this one, you can use calculator because you're going to plug in everything here in the calculator to get negative 5. Okay? On this example, yes. What about this example? Here, I'm going to, if you have 5 to the exponent log to the negative 5, and the number here is 1.7. If you check this one, it's exactly the same, this rule. Rule number 5, the second part. 5, which is the number, log to the base 5, which is exactly the same number here. And the x is 1.7. So the result is going to be the x, which is the number here. The number here is 1.7, so I'm going to write down 1.7. That's if they give you examples with the rule number 5. Also, I think you can do it using the calculator here also. You can use the calculator here. Plug in 5 to the exponent log to the base 5 is going to be 1.7. If you want to use this rule, it's going to be the same thing. But if you have examples with rule number 1, rule number 2, and 3, you can't use calculator. Let's do an examples about the first 3 rules. I'll give you time to write down. So let's do this example. If you have 7 log to the base a 7x to the power 5 y. So you see, be careful here. 7x, that means 7 times x times y. So I'm going to use the first rule. When I have multiplication between numbers, I can convert the multiplication to addition. So this one, the first step is going to be log to the base a. The first number is 7. It's not going to fit here. It's not going to be this space. It's going to be log to the base a. The first number is 7 plus log to the base a. The second number x to the power 5 plus log to the base a to the y. Now we're done using the first rule, so everything is fine. Now I'm going to check here this one. If I have log to the base number with the exponents, I can use rule number 3. I'm just going to move the exponents here in the front. So this one is going to be log to the base a to the 7. By the way, you're going to move the exponent in the front this log, not in the front this log. No, in the front this one. So give me plus, here is the 5 log to the base a to the x plus log to the base a to the y. That's it. This is the result for this example. So that's they're gonna ask you, simplify this one. So you have to use these 3 rules. Let's do another example. If you have log to the base 15 2m over s. So now we have division between the numbers. So I'm going to use the second rule. The division is going to be minus. So it's going to be log to the base 15 2m minus log to the base 15 s. Then now 2m, that's mean 2 times m. So on this part, I can use the first rule. The multiplication is going to be addition. So we're going to add these 2 numbers. So it's going to be log to the base 15 2 plus log to the base 15m minus log to the base 15s. That's it. This is the solution for this example. Now, if they ask you to write down a single log, for example, if they give you like this one, you have 2 log to the ax minus log to ay. So the first thing we have to do it here, check this part. There is a number in front of this log. That means this number is the exponent. So I'm going to write down log to the base a x squared minus log to the base a to the y. Now, if I have minus between 2 log, the minus is going to be division. So it's going to be log to the base a x squared over y. So I convert this one to a single log. That's it for this example. This is, so 2 cases, if they ask you to write down this one, simplify this one, like this example, or if they ask you, they give you the last step and you have to write down to a single log. One more questions. If you have log to the base a t minus log to the base a to the s with 2 parentheses plus 4 log to the base a to the u. So check, first of all, they put these in parentheses, that means they're telling you go ahead, work on this one. And on the second part, there is a number in the front of the log. So this number is an exponent here. And I have minus between 2 log, this minus is going to be a division. So this part here is going to be log to the base a t over s plus, here is the log to the base a, this number is an exponent, so it's going to be u to the power 4. Now, next step, I have addition between 2 log. So the addition is going to be, the first rule is going to be multiplication. So this one is going to be log to the base a t over s times u to the power 4. You can write in times, or you can simplify it more by writing down log to the base a t u to the power 4 over s is going to be the same thing. So it's up to you. Both this is going to be right. If you want to write down like this, if you want to write down like this, it's going to be right. That's if they give you this part and they're going to ask you to write down to the single log.